Alright, all you cats and kittens, trademark and flashback to 2020. I'm here with another coding problem. It's by yours truly. And I want today to do a little bit of directory searching. So what does that mean? I'm looking to do a coding problem that looks into finding duplicate files in a directory structure based on their content and grouping them together. So this is not exactly a classical problem, but it is a medium problem on Leetcode, problem 609, find duplicate files in a system. It actually could be quite a practical problem, right? Obviously, operating systems have some sort of, they may have some sort of procedure to find duplicate files based on size. Now, an actual implementation of this might be fairly complicated and whatnot and require a lot more intuition than maybe something like for an interview problem we might want to use. But in the meantime, we'll take this as it is on its simplest level and start to maybe dig into this. It seems like more people dislike than like this problem. I happen to think the way that I want to solve this problem, which I'll get to in a bit, it feels to me like one of these types of problems that I kind of like. Okay, because it lets you kind of use your intuition about fast searching. So let's read through the problem. Given a list of paths of directory info, including the directory path and all the files with the contents in this directory, return all the duplicate files in the file system in terms of their paths. You may return the answer in any order. A group of duplicate files consists of at least two files that have the same content. A single directory info string in the input list has the following format. And basically, blah, 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 root slash all the files down, separated by a space with the file, and in parentheses is the content of the file. Okay, so what we're trying to do is find all the files within the system after we traverse this directory structure that have the same content. Okay, so the first thing that's making me think here is that all these files are going to have different names, but they're going to have the same content, right? And we want to be able to quickly group by content. First thing I'm thinking is some sort of hash table, hash map, right? Because we want to be able to access a group and add members to that group as we traverse this directory, right? Like, so as the group membership expands, you know, we want to be able to always reference this group easily without having to search again for every file. And this is what really the advantage of a hash map is. So I feel that we might want to, in fact, use for our hash map the key as the content of the data. So that's interesting. Like the content in it, you can imagine in a real file would be huge, right? So in a real life scenario, you might not want to use the key as the content. A content is the key if you're implementing a similar situation. But again, remember, as I mentioned in the beginning, this is like an idealization of a real life scenario, right? For the purposes of a coding interview. But it still can be applicable in real life, right? Depends on the situation. So it means there are n files with content, f1 content, f2 content, fn content, respectively, in the directory root/dm. Note, n is greater than or equal to 1, and m is greater than 0. If m is 0, the directory is just the root directory. Okay, so that means just the recursion path is the root. The output is a list of groups of duplicate file paths. For each group, it contains all the file paths in the files that have the same content. A file path is a string that has the following format. So basically, directory. So this is standard directory listing data structure, right? I mean, there's nothing too crazy about this. Okay, so here's an example. We have root/a space 1.text abc. ABCD is the content, and we have within this entire input array, the array is an input array of strings. All of these strings represent directory and a path, and as you can see, some of these are duplicate files, right? So we have 1, 2, 3 duplicate files here, and we have 1, 2. So we have 3 duplicate files of EFGH, and we have 2 duplicate files of ABCD. Okay, and the output here, if you look at it, there's 2 this is a list of lists, right? And the inner list is a list of all the files that are duplicate for us, all the directory structures that are duplicated for a specific file. Okay, so again, there are 3 for EFGH, right? So EFGH, if you can imagine this is a map rather than a list, EFGH would have files root/a1/2.txt, root/cd4.txt, and root/4.txt, all referring to the same exact content, so they would be duplicate files, right? Even if they're named differently. Okay, the same thing goes for the next, the element of the list. And remember, because there's only 2 files, right? There's only 2 sublists, right? So if there were 10 separate different files with different content, there would be 10 separate sublists. Okay, and that includes their clones, right? So essentially, this is a many-to-one relationship or many-to-few relationship that we're trying to create. If we have some sort of, graph structure that we're using to represent the functional relation here. Okay, and the same thing for here. We have two different groups of files because we have 2 different contents, EFGH and ABCD. Okay, so we have 4 files, but only 2 unique files. Okay, so basically it boils down to finding the unique files and their root. So the first thing I want to do is, as I said, I want to create a hash map structure. So I'm going to create some kind of structure to store my content, right? So I'm going to call this content map equals new hash map. Okay, so again, this is where, as I said before, I'm going to use the file content as a key. Okay, maybe unconventional for a real-life practical situation, but in an abstract data sense, it probably could make sense. String result equals new array list. So I'm not a huge fan when problems do this, but I mean, I understand because there could be multiple ways to obtain the final result, but it kind of sucks because I'm already using the hash map data structure as the main operational data structure, and I have to have this return type data structure that's a list, right? So there's actually, there's a slight difference, and there may be an efficient utility method to convert between the two, but I'm just going to do it manually when it gets to the pen. Okay, so the thing is what we want to remember. Now let's get to the meat. Now the meat of this I think is going to be a little bit involved, but like bear with me because there's going to be a lot of parsing going on, right? So the first thing we want to do is we want to iterate through all of our paths, right? So we have our paths as input to our system, right? Okay, so now we have to start breaking apart each path, okay? Because the way that we find the actual directory is we break the path into parts. So first we split the path by a space, okay? You see here, this space is the delimiter between the directory and the file name in all cases. So we can safely split every path by the space, right? Now I want to actually separate the folder from the file name, right? So I'm going to call this parts 0, right? So the split, this paths will split the path into several pieces, and I wanted to call this not path, parts, and then this 0th part, the first part will be the folder, and again, check it out, the first part is the folder, root/a, root/c, root/c/d. It's actually quite elegant in this example, in this somewhat contrived example. Now, now that I have the path split into parts, it comes the actual tricky part. Now we have to iterate through each of the parts, right? Because remember, each of these parts contains several files, right? So parts.length I++. So we have to split each of these files, right? So how do we split each of these files up? Okay, each of these parts into a file. We have to iterate through each of these parts. We split the file by space. So everything in parts 1 to n, 0 again contains the folder, and everything greater than 0 contains the individual files and their paths, right? Relative to the root. So we have to go through each subpath string, and I'm going to call this content parts, right? Content parts. What am I calling this content parts? Because I'm now splitting the content from the file name, because the crux of this problem is that there's a lot of nested pieces mixed together. Okay, so that's not conceptually too complicated. You just have to split the string along the appropriate boundary, right, to separate the different parts. And so as you notice, I'm doing this because I want to get the content parts out of there, the groups of content parts, and I know that I hit a content part in each path because they're delimited by this. But I can't just put I just can't put this parentheses by itself as the splitting variable, because if I or the splitting delimiter, because then this will read like a regex expression, and then there's an error that corresponds. I'll show you later what will happen if I do that. But that's why I use these two double backslash escape characters, right, to split along the parentheses. So, and then if I string content path equals content parts 0, now I'm getting the path, right, because there's this path for each of the pieces of content. And then the content itself equals content parts 1 dot replace. Why am I doing this? Replace. Now this is the word a little bit of a trickiness comes into play, but it's not that much really, not that intuitive. But so I'm splitting the content. How do I know? How do I get all the content? Well, invariably the content starts at a parentheses, open parentheses, and always closes at an end parentheses. So I can replace the end parentheses since I've already split along the open parentheses, right? So that's gone, and then I just have everything left, and then the end parentheses. I can split along the end parentheses and just replace the end parentheses with a space, and voila, I got my content. See, eliminate, content, eliminate, and therefore ABCD is the content. Then, now, once I have my content, here's where the magic of the map comes into play. Path list equals content map dot get or default, nice little Java 7 plus convenience method, array list. Okay, so now for each piece of content, I want to get a list of all the files that are duplicate and associated with that content. So that's what I'm doing here, and then I'm tasked to add the entire folder path. The folder equals the folder plus a slash plus the content path, which includes the file name, for each element of content that I discover while iterating through this loop here. So put content path list. Okay, so that looks like, so basically in my content map, I'm re-adding the path after I either create a new list or you take the existing list for that specific key value in the map and then re-adding it back to that key value. So I keep adding the paths. Now, what should we do? What's the next thing that we do? Now that we have our content list figured out, I think all we have to do is convert to that list of list data structure that I was talking about in the beginning. And you guys might know a better way of doing this, but I will look it up at some point, but it can't be too difficult. For now, for the brevity of this video, sake of brevity, I'm going to continue with what I was originally saying. Key.size greater than 1. Result.add content map that get that key. Get key, not get dot key. I hate. Okay, cool. So now, there's a few things going on here. I'll get to that in a second. And then finally, I wanted to return the result. Okay. That should be it. Line 22, of course. I'm used to coding in Python and Java, so I mix stuff up. Line 13. Let's see. This was invariably content map. I'm going to have some issues because Java always does and coding always does. So what else is the problem here? Content path list. It's not path. Yeah. Okay, accepted. Bam. Let's see. Submit. And accepted. There you go. Faster than 50% of submissions, and memory usage less than 89.56. So really good on the memory, okay on the speed. But check it out. So if we look at the solutions, it's possible that there's solutions that are going to hit TLE, time excluded. And basically what the solution, the brute force method, was saying was that search through each file, iterate, and or do a DFS through each file in the file structure, and then through each iteration add that piece to the list. So that's where the map comes into play, right? Because the map made this really fast for us. Okay, we don't have to do that. Oh, I forgot to say here, content map get key greater than size 1. Remember, this is where reading is important. Reading is important because you'll see that an output of the list of groups, for each group it contains the file paths of all the paths that have the same content. Okay. A group of duplicate files consists of at least 2 files that have the same content, okay? Because we're trying to find files that have duplicates. So if my size was equal to 1, then if I didn't put this condition here, I would invariably put in unique files into this list. And that's a no-no. That's not something that we want to do, okay? We want true duplicates in this list. So that's that. So again, going back to the solution, just telling you right now that there are solutions which are brute force solutions. They're not actually loading now. It's funny. That indicate that are have a much higher time complexity. And this is the hash map solution, which I can copy. I use my own implementation. Wow, look at that. That's not even Java, and that's not filled out at all. But the point is that the hash map complexity time complexity is much smaller than the time complexity of the brute force approach of iterating through the directory paths. So that's about it. I hope you enjoyed this video, and like, subscribe, leave some comments in the comment box below. If you have any questions or want to see more videos, just let me know. I'm doing these videos as often as I can, and your support means a lot. So thank you very much, and I will see you again another day.